Let's now apply our understanding of the normal distribution to work on this problem as an example. And at the start of this example, we are given SAT scores being our data. SAT scores in the year of 1997. And once again, notice that we have a plural here, but didn't indicate how many. So clearly this is a population data. So I am going to use a capital letter X as a random variable to represent an SAT score in 1997. And so clearly speaking, X here has to be a continuous random variable, and it's representing a population data. Continuing to read the description of the problem, we were instructed, it was indicated that SAT scores in that year 1997, this phrase here is saying the scores were normally distributed. So now indicating that our population data is normally distributed, is being distributed by a normal distribution. And then further, reading further into the problem, and by the way, this is so far only the description of the problem of the data. And so now we know that our population has a mean being 950. So I am now going to put it here. And having a standard deviation, a population standard deviation of being 150. So now this is a symbolic expression of our data. And at this point in our experience working with the normal distribution, then we are going to draw an empty bell curve. The horizontal axis here is to represent all values from low to high of the random variable X. And being normally distributed, our PDC has to be a nice looking bell curve. The specialty of the bell curve is the mean value 950 must be placed right at the middle of the bell curve. The standard deviation, population standard deviation, even though not clearly seen in a picture, but it's always a good habit to note it somewhere near the bell curve. From the data given to us with its description here, we now have the question asking us to find the probability where our random variable takes value below 600. So in my empty normal distribution, already prepare for the problem to work, 950, the mean value being right at the center. Population standard deviation is being noted here being 150. So 600 at start makes sense to be simply somewhere. And keep in mind that we do not need to be too precise about how far it is in terms of how many standard deviations. That's not what we need right now. All it needs here is that somewhere makes sense to be to the left-hand side of 950 because it's below mean. And now we're going to be more importantly making a shade that describes we're looking for the probability. So this shading area represents the probability where our variable takes value below, meaning to the left of 600. And remind yourself again that this horizontal axis is where all values of the random variable X are being arranged at. And so now apparently that we're not working on a standard normal distribution. Instead, we're now working with some general normal distribution where mean is no longer 0 and standard deviation is no longer 1. So learning from our earlier video lesson, then it is clear that we need to, our first step here is to find a z-score of 600. It is just my own habit that anytime I'm doing, because later on we will be working with many different value of the random variable. So we have to end up finding many different z-scores. So here I'm using a subscript 600 here to indicate that this is specifically the z-score of 600 that I am looking for. So here the math for finding z-score 600, the value that we're looking at minus 950 and divided by 150. Calculation comes out to be, and usually rounded to 2 decimals, minus 2.33. Once the z-score is calculated, what it means now is our probability on this normal distribution where the random variable takes value less than 600 will exactly be the probability that's on the standard normal distribution. We're looking at a z-score value below negative 2.33. Or thinking in terms of area, then this shaded area is exactly the same as the area on the standard normal distribution, where we're shading z-score below negative 2.33. And now to find this area, or to find this probability, the answer is just as directly as using a technology, some technology. I use my LSND. Feel free to use my LSND program if you have it. And when it's asking for z-score, we're going to provide negative 2.33. And the entire point of the LSND program, once again, is to quickly obtain the area on the standard normal distribution. We want to find the area to the left of this designated z-score. So now calculation comes out being 0.00999031, and since this is our final answer, it's usually good that we can round this to 4 decimal places. Computations is these. Watch out for different rounding requirements in every different problem. The same problem and data given to us. We are now asked to find the probability where our random variable x takes value above 1150. So on another empty prepared bell curve here with the mean at 950 and standard deviation 150. Let's now lay down the shading that described our probability question. So we are looking for the probability where our random variable stays above, and keep in mind again, be aware that there could be time where we have equality signs in our inequality, but it's okay, it will not change the way how we do the problem at all. So here once again, probability where our random variable takes value above 1150. So without the worry to be too precise on scale, all it needs to make sense here is that 1150 must be to the right hand side of the mean value somewhere. So I'm going to pick a value here. I'm going to say this is where 1150 is. All it makes sense here is that 1150 stays to the right hand side of the mean. And looking at value of x being above 1150 means we are going to produce a shaded area to the right hand side of 1150. And so this value of the random variable x is not on the standard normal distribution, and what we have here is only some general normal distribution. So the first step is to find the z-score. Z-score for this value being 1150, I am using a subscript to indicate that here we're finding the z-score specifically for 1150. The math for finding z-score, here it comes, 1150 minus the mean in the middle of the bell curve and divide by the standard deviation 150, and that standard deviation was noted somewhere on our data, on our normal distribution curve. Calculation comes out to be 1.33, positive 1.33 in 2 decimals. And like I said again, that very commonly that in a lot of computations, a z-score of 2 decimals is usually required. But keep an eye on any other different requirements on how far to round for z-score before we proceed into finding the area. But once this z-score is calculated, once again, what it means is that this area we're shading here, representing the probability on our bell curve having the random variable x taking value above 1150, this probability is exact same value as the probability on our standard normal distribution, where z-score is above positive 1.33. And this mean value is equivalent to z-score 0, so 1150 is equivalent to z-score 1.33. So this shaded area would be the same if you would imagine that, if this curve here would be the standard normal distribution curve where all of these values are standardized into z-score, then this would be the same amount of area on that bell curve, the standard normal distribution. And so now we have learned already that on the standard normal distribution, to find an area to the right hand side of a given z-score, then what it takes now, the first thing, we find our area, and we can find that through our LS&D program again as a tool. We run the LS&D program with z-score given to be 1.33, and this is going to give us an area to the left. But once we have that area to the left, and we subtract it from 1, and the answer now comes out to be, now first running my LS&D program, 1.33 z-score has an area to the left being 0.9082409. But then this area is of course subtracted from 1. And my final calculation comes out to be 0.0917591. And once again, usually these answers are rounded to 4 decimal places, but do watch out for different rounding requirements here and there in different problems. The same data with the description as given here, and we already had an empty bell curve with mean right at the middle 950 and standard deviation sigma equals 150. We are now asked to find the probability that on this general normal distribution we're having our random variable x taking values greater than 700 and at the same time less than 1000. Or in other words, here we're looking at x being anywhere between this interval from 700 to 1000. And once again, watch out that sometimes we might have equal signs included here, but it won't change the way how we do the problem. And let's now go ahead and make a sketch. 700 is somewhere to the left hand side of 950. How far is good enough? That shouldn't matter. So 700, all it needs to make sense here is a being a value to the left hand side of 950. 1000, what makes sense is somewhere to the right hand side of 950. And it makes sense that the distance from 1000 to 950 should be shorter, should be looking shorter than the distance from 700 to 950. But here we have the upper limit of our interval, and here's the lower limit. So the probability where x takes value anywhere between 700 and 1000, this probability question is translated graphically as a shaded area between 700 and 1000. And here we're looking at two different values on our curve here. So be aware that each one of these will have a corresponding z-score. So I am now going to find each one of the z-score here individually. So z-score of my value 1000 on this bell curve is going to be done by the standard math of z-score 1000 minus 950 divided by 150. And it gives me, calculation comes out being a positive 0.33. The other value being 700, and now I'm about to find a z-score for 700. The calculation now, the formula comes out 700 minus 950 divided by 150, and that gives me negative 1.67 after calculation. And so once both z-scores are given, it's never a bad idea at all to label the z-score corresponding to each of these values on our bell curve. So 700 is equivalent or corresponding to z-score negative 1.67. 950 right in the middle is the center, so z-score is 0. And 0.33 is the z-score correspondingly for 1000. So this area on our currently general normal distribution would be the same. The area where x is between 700 and 1000. This area, once again, would be the same with the area on our standard normal distribution, where z-score is between negative 1.67 and 0.33. And at this point, make sure anyone viewing this video have seen my earlier videos about how we operate in finding areas on the standard normal distribution. But to get this problem done from where the greater z-score is, we are going to find the left area, or the area to the left of that larger z-score. So I'm using my tool here, the LS&D program tool. But keep in mind again, there are plenty of other softwares out there that can handle the left area to any specific z-score coming out at once. So LS&D running on the provided z-score being 0.33. And I will also run my program again for z-score negative 1.67 and subtract the two answers. Remind yourself again from my earlier videos on the standard normal distribution that this answer after the LS&D program will give us what's so-called bigger area. And this answer after running the LS&D program on the lower z-score is going to give us what I used to call smaller area. And so on any bell curve, all it takes now is just the bigger area minus the smaller area. That gives us the area between. And once again, let's have a look over at my LS&D program. So the upper z-score 0.33 gives me area to the left, or the bigger area being .6293. With the negative 1.67 for z-score, the area shaded to the left would be, as indicated here with my LS&D program, 0.0474597. And now, once again, all we do is just bigger area minus smaller area. And once we arrive at the very final answer, which is what we're looking for, then it's usually a good idea to round it to 4 decimal places. So final calculation comes out after rounded to 4 decimal places, gives me 0.5818. the same data with description as given here. Now we are asked to find the probability where x is less than 550 or x is above 1200. And so now I am going to sketch the shading area that described our problem. And once again, our problem here is looking for the probability where x is less than 550. So what makes sense about 550, and the only thing it needs to make sense, is that 550 is somewhere to the left-hand side of 950. So now I am going to, according to the requirements, I'm looking for area shaded to the left of 550. Or it's indicating additionally we're including the probability for those x value that stays above 1200. So 1200 is a different value on our horizontal axis here for the x values, but stays somewhere to the right hand side of the mean. So 1200 is somewhere here, and the requirement says we want to look for additionally, aside from x less than 550, we additionally look for the x is greater than 1200. So there we produce a different area here, but disconnected from the other area. And so if you recall from those video lessons on the standard normal distribution that we have done earlier, then area is being broken up like this, and I tend to call them myself the disconnected areas. And anytime we're running with a problem where our area is being accumulation of disconnected areas like this, and the only fundamental, once again, to remind everybody, is that all we have to do is to find all individual pieces and total up. And now we are going to find z-score. This x value 550, we are now going to find its corresponding z-score. So I am using that subscript 550, indicating that the z-score we're about to find is specifically for 550. So on this bell curve where center or mean is at 950, then we're going with the value being 550, subtracting 950 and divided by the standard deviation, 150. Calculation comes out to be negative 2.67. And the z-score for the other value of x. Now I'm going to use the indication z-score with a subscript 1200, just simply to indicate that the z-score we're about to find is for 1200. The math here is 1200 minus 950 divided by 150. Calculation comes out to be 1.67. What it means once z-scores are calculated on these values is that 550 is at z-score negative 2.67 and 1200 is at z-score 1.67. Or in other words, on the standard normal distribution, then we are looking for the area shaded to the left of negative 2.67 and also the area shaded to the right hand side of 1.67. Remind yourself again, mean value right in the middle is at z-score 0. And so to find each of the individual pieces here, then we are going to use our LS&D program. This shaded area, since being shaded to the left of negative 2.67, the answer coming out for that is simply as just running the LS&D program, and with given z-score negative 2.67. So with z-score negative 2.67, we're looking at the answer here being 0.0037926. This other answer, where my arrow points to, is the area that's shaded to the right hand side of z-score 1.67. So we will run our LS&D program for the given z-score being 1.67. But keep in mind this time that we need to subtract the answer after the LS&D program from 1. Or in other words, on my screen here, when we're entering 1.67 for into the z-score box of my LS&D program, this answer here is only the area shaded to the left of 1.67. So we need to subtract that area from 1. So here in the next step, 1 minus 0.9525403. So each of these is one individual piece, and as I said, we have to find all individual pieces and total them up. So the next step now is to add all of these two little work together, all of these two results together. So final calculation comes out to be 0.051253, and usually these final answers are rounded to 4 decimal places. So at your very final answer, usually it is rounded to 4 decimal places, being 0.0513. But once again, do look out for different rounding requirements in every other problem.